Now in this practice problem, we are going to write a program to generate Fibonacci series. We'll see two variations of this problem. First, we'll try to write a program to generate first n Fibonacci numbers. Let's say if n is 5, we want to generate the first 5 Fibonacci numbers. The other variation is to print Fibonacci series up to a certain number. Let's say if the number is 15, we want to generate the Fibonacci numbers less than or equal to 15, which are these. Alright, but before writing the program, let me give you a quick overview of what Fibonacci series is. Some of you might already know about it, but let me give you a quick overview. So the first two Fibonacci numbers are 0 and 1, and the every next number will be the sum of the previous two numbers. For example, 0 plus 1 is 1, so 1 will be the next number. And 1 plus 1 is 2, so 2 is the next number. And 1 plus 2 is 3. Similarly, 2 plus 3 is 5. 3 plus 5 is 8. So that's how we can generate the Fibonacci numbers by summing up the previous two numbers. Now let us break down the problem logically step by step and try to analyze what is happening in each step. Once you figure out the logic, converting it to the program will be very easy. So the first two Fibonacci numbers are 0 and 1, right? So let's call them as A and B. Now the next number, let's call it as C, will be the sum of the previous two numbers A and B, right? So C will be A plus B, which is 0 plus 1, which is 1. So the next number in the series is 1. The series now becomes 0, 1, 1. Now the next number after this will be the sum of the last two numbers 1 and 1. So A and B should become 1 and 1. Previously A and B are 0 and 1. A was 0, B was 1. And C was 1, which we generated in the previous step. So what should we do to make A and B as 1 and 1? We should make B as C, A as B, right? That's how A and B will now refer to these last two numbers 1 and 1. Now the next number C will be the sum of the last two numbers A and B, whose sum is 2. So the series now becomes 0, 1, 1, 2. Again here we need to make B as C, A as B. Right? So this process continues. Now the next number C will be the sum of last two numbers A and B again, which will be 1 plus 2, which will give you 3. So the series now becomes 0, 1, 1, 2, 3. And again we need to make B as C and A as B. And the next number C will be the sum of A plus B. So we can continue this process to generate as many Fibonacci numbers we want, right? Now let us convert this logic to code. So I've created a new Python file Fibonacci_series.py inside this practice problems folder. Alright. First let's write the program to print first n Fibonacci numbers. Let's take n value as 10, or instead we can also take user input using input function. Alright. But let's keep it simple and let's assume n value is 10. Now what are the first two numbers in the series? They are 0 and 1, which we can represent using A and B. So let's take A is equal to 0, B is equal to 1. So here A comma B represent the first two Fibonacci numbers 0 and 1. So let's print them by using print of A comma B. Now what happens with this print function? It prints the value of A and B with a space separation, and in the end it will append a new line, which means the next output will start from the new line, isn't it? Let's say in the next line I'm simply printing value 20. What happens if I run it? So as you can see, 20 is printed in the new line. But we want to print the whole series in a single line, which means we don't want to print the next number in the new line. So what we can do is we can use end parameter and we can specify the value as single space. Now what happens if you try to run it? Now it will print values of A and B with a space separation, and it will add a space at the end. It will not create a new line, which means if we print the next output, it will be printed after a space and not in the new line. Alright, let me remove this. Okay, now we want to print first n Fibonacci numbers. We already printed two numbers, right? So we need to keep track of how many numbers we printed. So we have printed two numbers till now. So let's create a variable count and let's assign 2. This count variable will help us to keep track of how many Fibonacci numbers we printed so far. Alright. We want to print the first n Fibonacci numbers, right? Which means as long as count is less than n, we want to generate the next number and print it. When count value becomes n, it means that we already printed n numbers and we want to stop generating the next number and break out of the while loop. And that's exactly what this condition helps us do, right? If count is less than n, this will be true, and so it will execute the while loop. And once count becomes n, this condition will be false, and so it will break out of the while loop. Now inside this loop, we'll generate the next number c by adding a plus b. And let's also print it. Let's print c, comma, let's also use n parameter with a single space so that the next number will be printed after a space and not in the new line. Now once we print the next number, we also want to increment the count, right? To keep track of number of numbers we printed so far. Now once we generate the next number c, what do we want to do? We want to make b as c and a as b. So a comma b should now become b comma c. What is the meaning of this syntax? Let's assume a is equal to 1, b is equal to 2, c is equal to 3. Now what happens when we write a comma b is equal to b comma c is Python will first evaluate the right side and it will create a tuple with values of b comma c. We will discuss about tuples in future, but think of it like a sequence with values of b comma c. So Python will first evaluate the right side and it will create a tuple with values of b comma c, which are 2 comma 3 in this case. Now this value 2 will be assigned to a and value 3 will be assigned to b. So that's how we can change the values of a comma b to b comma c. Now in the next iteration, again we're finding the next number in the series by adding a plus b, and we're printing that new number and we're incrementing the count by 1. And then finally we are updating the values of a and b to b comma c. And this process continues. Now how long will this process continue? As long as count value is less than n. Once count value becomes n, this condition will be false and so it will come out of the while loop. Now let us run the program and verify the output. Right click, run. This is the output. So as n value is 10, we can see that the first 10 Fibonacci numbers are printed. Also there is one extra step we can add here. So as you can see, whenever we print the number, we are specifying n parameter as single space, which means after printing the value, space will be appended in the end. So even after printing the last value, a space will be appended in the end and the next output will start from there. It will not start from the new line. For example, let's say once we are done, we want to simply print done in a new line. Now what happens if you try to run it? You can see that done is printed in the same line after a space and not in the new line. Because in the last print statement before this, while printing this 34, n parameter was a space, right? So space will be appended after it and the next output will start from here. So what you can do is you can add an empty print function here. So what will this function do? After this space, it will print nothing because we did not specify anything, but it will append a new line after it. So which means the next print statement will print the output in the new line. Now if you try to run it, right click, run, you can see that done is printed in the new line. Alternatively, what we can do is instead of adding a empty print function, so in this string we can add /n and we can write done. So /n indicates a new line, right? So if you try to run it again, so it automatically creates a new line and then it will print done. Now here in this print function, we are not specifying any end parameter, right? Which means by default it will take /n new line, which means it will append a new line and so the next outputs after this will start in a new line. All right. So we can do it this way as well. But in case we are not trying to print any message like this, you can simply put a empty print function so that any output after this will start in the new line. Now, if you remember from the while loops part 1 tutorial, we discussed that we can use two different approaches to write while loops, right? First is by using this while condition kind of a syntax, which is what we have used while writing this program. The other one is by using while true plus break kind of a syntax. We discussed that if the condition is very simple, we can go ahead with this simple while condition kind of a syntax. But in case if exit condition depends on user input, or if there are multiple exit points, or when complex logic is involved, it will be much easier if you go ahead with while true plus break kind of a syntax. In this particular problem, the condition is very simple, right? We just want to check if count is less than n. So in this scenario, while condition kind of syntax is better. But this is not a hard and fast rule. It is just a guideline to make it easier to write the code. But if you want, you can even use while true kind of a syntax as well. Let me take the same code and convert it to while true plus break kind of a syntax. So in this syntax, we'll be using infinite loop, which is while true, right? Now this is an infinite loop, right? Because the condition is always true. This will run forever. So we want to specify the breaking condition explicitly by using an if statement. Now what is the breaking condition? When do we want to stop? Once we print n numbers, we want to stop, which means once count becomes n, that's when we want to break out of the while loop. So this is how we can use while true plus break kind of a syntax. Even though both these code snippets are a bit syntactically different, what they're actually achieving is the same thing. The major difference between both these syntaxes is while using this while condition kind of a syntax, we are specifying when should Python execute this code. So as long as count is less than n, we want Python to execute this loop. Now once this count value becomes n, this condition will be false, and so it will break out of the while loop, right? But here we are using an infinite loop, right? So we explicitly mention the breaking condition, which is if count equals to n, then we want to break out of the loop. That's it. So let me run the program and show you. As you can see, in both the cases, we got the same output. But in this particular problem, as the condition is very simple, it is better to go with this while condition kind of a syntax. There will be a practice problem discussed in the next video where we'll see a scenario where while true kind of a syntax will make more sense. Alright. So far we have written a program to print the first n Fibonacci numbers, right? Now let's see a variation of it where we want to print Fibonacci numbers up to a certain number n. Let's say if n is 15, we want to print the Fibonacci series till less than or equal to 15, which is till 13 in this case. If n is, let's say 21, we want to print the series till 21, right? Because the next number is greater than 21. So let's see how we can implement this. So we want to print the Fibonacci series up to n. So let's take n value as 20. Or to avoid any confusion, let's call this as m. Alright, let me put it as m. M is equal to 20, so that we don't get confused with the previous problem where we are printing first n Fibonacci numbers. Alright. So we want to print Fibonacci series up to number m. Now the first two numbers in the series are 0 and 1. So we'll take a as 0, b as 1, and we'll print a comma b with n parameter as space, just like in the previous case. This is the same thing. Now in the previous scenario where we want to print the first n Fibonacci numbers, we need to keep track of count, right? But we don't need to keep track of count here because we want to print the series up to a certain number. We are not concerned about the count here, isn't it? Now what should be the condition in this case? In the previous scenario, we are checking the condition count less than n, right? But here we are not concerned about the count. If we assume the next number to be c, we want to check if this next number c is less than or equal to m. If it is true, then we would want to go ahead and print that number. And if not, we want to stop there and come out of the while loop, right? So how can we write the while loop condition here? While c less than or equal to m. But as you can observe, we are using this c value within the condition, right? So before starting the iteration itself, c value needs to be updated. So let's take c as a plus b. So the first two numbers are 0 and 1 represented by a and b, and we are finding the next number c by adding a plus b. Now initially what will be the value of c? It will be a plus b, which will give you 0 plus 1, 1, right? Now what are we trying to do here? As long as this c is less than or equal to m, we want to print that number. Now once we print the next number represented by c, we want to update the values of a comma b to b comma c, right? Same as the previous case. And as we are using the next number c in the condition. So before going to the next iteration, we need to update the value of c as well, which means we need to update the next number c as a plus b. Now in the next iteration, again, Python will check if the next number generated is less than or equal to m. If it is so, it will go ahead and print it and it will continue the same process. So it's very important to understand the entry point of the while loop iteration, right? Because we are using this c within the condition, we need to make sure this c is updated before entering the next iteration. Now let's say at some point of time this c value becomes greater than m, which is 20 in this case. So this condition will be false and so it will come out of the while loop. Let me also add an empty print function in the end so that the next outputs can start in the new line. Okay, now let me run the program and verify. Right click, run. As you can see, it correctly prints the Fibonacci series up to the value of m, 20 in this case. So the next number is 8 plus 13, 21, right? Which exceeds 20. So it will stop at 13. Now instead of 20, what if we have 50? Let's run and see. Right click, run. And as you can see, it prints till 34. Because the next number is 21 plus 34, which is 55. It exceeds the value of m. So it will stop at 34. So that's how you can print Fibonacci numbers up to a certain number m. Now we have written the code to print the first 10 Fibonacci numbers and also to print Fibonacci series up to value m. But many times when we solve problems during the interviews or when we use platforms like LeetCode, we need to handle something called edge cases. So let me tell you what this means. If you go to this code snippet where we are printing the first n Fibonacci numbers, so instead of 10, what if n value is 2? So we want to print the first two Fibonacci numbers, which are 0 and 1. We just want to print these two numbers. And let's see if our program works correctly or not. Let me run the program. And as you can see, it successfully prints 0 and 1. So it works fine for n is equal to 2. Because what is happening when n is equal to 2? So we have a comma b as 0 comma 1. So we are simply printing a comma b. So it will print 0 comma 1. And count we are initializing to 2 because we have printed two numbers. And when it comes to this while loop, count less than n will be false because both are 2. So count is not less than n. So it will not enter into this while loop. So it will only print 0 and 1, which is the correct output. But what if n is equal to 1? Which means we want to print only the first Fibonacci number. So we want to print only 0. And let's see what is the output our program is printing. Let me run it. So as you can see, it prints 0 and 1. But we expected the answer to be only 0. We just want to print the first Fibonacci number, right? The problem here is we are by default printing the first two Fibonacci numbers 0 and 1. And after that, from the third Fibonacci number, we are iteratively printing inside this while loop. So by default, whatever is the value of n, we are printing the first two numbers, right? For n is equal to 2 or greater than 2, this is not a problem. But when we have n is equal to 1, we just want to print one number, but our program by default prints the first two numbers. So we need to handle this case. Same is the case with n is equal to 0. So when n is equal to 0, it means we don't want to print anything, right? So we don't expect anything to be printed. But if you run our program, again you will see that the output will be 0 and 1. So these are called edge cases. Like if the input is 0 or 1, you have to check if your program is working as expected or not. Now let's see how we can handle this edge case. Firstly, let's handle the case where n is 0. So when n is 0, we don't want to print anything, right? So what we can do is we can call a simple empty print function. It doesn't print anything, isn't it? Now if n is 1, which we can check by using elif, n equals to 1, then what should we do? We only need to print the first Fibonacci number, which is 0. So we can simply print 0 here, right? Now for all the numbers which are greater than 1, this logic works perfectly fine. So what we can do is we can take this logic and we can put it inside the else block. Now what is happening if n is 0? So this condition will be true. So it will print nothing, right? And if n is 1, then what happens? This will be false. So it will come here. And if n is equal to 1, it will simply print 0, right? So let's check it. Right click, run. So you can see that it only prints the first Fibonacci number. Similarly, if n is 0, let me run and show you. So you can see that it doesn't print anything. Now for n greater than or equal to 2, let's take n is equal to 2. It successfully prints the first two Fibonacci numbers. If n is equal to 5, you can verify that it successfully prints the first 5 Fibonacci numbers. And also here we are not expecting any negative values for n, but in case if your problem says to handle that as well, you can add one extra condition like if n is less than 0, you can print a message like number can't be negative or something, right? That way you can handle. Now let's see how we can handle the edge cases for printing Fibonacci series up to m. Even here we are by default printing the first two numbers 0 and 1, right? And following that we are iteratively printing the next numbers. So for m is equal to 0, we want to print Fibonacci numbers up to number 0, right? So which means it should print only 0. So let's handle the condition for m is equal to 0. If m equals to 0, we just want to print 0, right? Because here we're interested in printing the numbers up to m, up to 0. So it should print 0. Now for m is equal to 1, we want to print the series up to number 1, which means until less than or equal to 1. So we want to print the first three numbers 0, 1, 1 here. But anyway, our program works perfectly fine if you want to print more than two numbers, right? The only problem is when you want to print less than two numbers. So this code can handle the case for m is equal to 1 as well. So what we can do is we can put an else block and we can add all this code in the else block. Now if m is equal to 0, this condition will be true. And so it will simply print 0. Let me run the program and verify. So this is the output, right? Printing Fibonacci series up to m, it prints 0. Now what happens if m is 1? So this condition will be false. So it will go to the else block and execute this code. So it will work perfectly fine. Let me run it and show you. So it prints 0, 1, 1. Same is the case for any number greater than 1 as well. If you take m is equal to 2, you can see that it successfully prints the Fibonacci series up to number 2, which is as expected, right? 0, 1, 1, 2. So that's how you need to think about the edge cases while solving the problems. I hope you understood now. That's the end of the tutorial, and I hope this practice problem helped you understand how to use while loops in Python. I'll see you in the next one.